Good morning, dear student. Today I will discuss about the some important formula of differentiation. Now, first d dx of x power n. This is equal to n into x power n minus 1, right? Second d dx of e power x. This is equal to e power x. Okay, d dx of a power x is equal to a power x into log a to the base e, right? D dx of log x to the base e, this is equal to 1 upon x. Okay, d dx of log x to the base a is equal to 1 upon x into log a to the base e, right? D dx of sin x, this is equal to cos x. Okay, d dx of cos x is equal to minus sin x, right? D dx of tan x is equal to sec square x. D dx of cot x minus cosec square x. D dx of cot x is equal to minus cosec square x, right? Dear student, now I will discuss about other formulas. These are very important, you should care this one. D dx of sec x, d dx of sec x is equal to sec x tan x. D dx of cosec x, d dx of cosec x minus cosec x cot x, right? D dx of sin inverse x, this is equal to 1 upon under root 1 minus x square. D dx of cos inverse x minus 1 upon under root 1 minus x square. D dx of tan inverse x, this is equal to 1 upon 1 plus x square, right? Dear student, d dx of cot inverse x, this is equal to minus 1 upon 1 plus x square. D dx of sec inverse x, this is equal to 1 upon x under root x square minus 1, right? D dx of cosec inverse x minus 1 upon x under root x square minus 1. Okay, this is them. These are very important, right? You should learn these formula. Now I explain other sums. d dx of ax plus b whole power n, this is equal to n into ax plus b whole power n minus 1 into a. d dx of e power ax, this is equal to a into e power ax. d dx of a power bx, this is equal to b into a power bx log a to the base e, right? d dx of log ax to the base e, this is equal to 1 upon ax, 1 upon x. d dx of log bx to the base a, this is equal to 1 upon x log a to the base e. d dx of sin ax, this is equal to a into cos ax. d dx of cos ax, this is equal to minus a into sin ax. It's okay. d dx of tan ax, this is equal to a sec square ax. d dx of cot ax minus a cosec square ax. Okay, these are. Now come to next. d dx of sec x, sec ax, this is equal to a sec x tan x, d dx of cosec ax, this is equal to minus a cosec x cot ax, cosec ax, this is ax and ax, cosec ax cot ax, right? d dx of sin inverse ax, this is equal to a upon under root 1 minus a square x square. D dx of cos inverse ax, this is equal to minus a upon under root 1 minus a square x square. D dx of tan inverse ax, tan inverse ax, right? This is equal to a upon 1 plus a square x square. D dx of cot inverse ax, this is equal to minus a upon 1 plus a square x square. D dx of sec inverse ax, this is equal to 1 upon x under root a square x square minus 1. D dx of cosec inverse ax, this is equal to minus 1 upon x under root a square x square minus 1, right? So these are very important formula. Dear student, you have to learn. These formula are useful to find the derivative of some important functions, right? Now in the case of logarithmic differentiation, now I will explain here. Y is equal to, let y is equal to fx fx power gx, right? In that case, dy by dx is equal to y into log fx into g dash x plus g x into 1 upon fx into f dash x, right? This is a formula. We use this term. This is very important. We should use y is equal to fx whole power gx. In that case, d dx of y is equal to y into log fx into g dash x plus gx into 1 upon fx into f dash x, right? This is very important. General parametric form, let x is equal to phi t, right? And y is equal to psi t. This is the function of t. In that case, dy by dx is equal to d dt of y whole upon d dt of x, right? In this way we use to find the derivative of parametric form. Any problem you can use. Now come to Rolle's theorem. Rolle's theorem. To Rolle's theorem, fx be a real valued function defined in a closed interval ab. So fx is a real valued function, right, in closed interval ab, right. In that case it is continuous closed interval ab. It is differentiable in ab. F a is equal to fb. F a is equal to fb, right. There exists at least C belong to AB, open interval AB, and f dash C is equal to 0, right. So this is a Rolle's theorem. Here f is equal to fb. These two a and b values are equal in the function, okay, and C belong to AB. F dash C is equal to 0. This is a Rolle's theorem, okay. So there is a, for example, it is a curve. Here it is a and it is a B. It is B. So interval A and B, this point is C. C lies here, okay. So A and B are closed interval. In that case, these two values are equal. CFC, this is point C, FC, okay, CFC, that point, this point is CFC. So f dash C is equal to 0. F dash C is equal to 0. This is the concept. Second is Lagrange mean value theorem. Now I explain here Lagrange mean value theorem. What do you mean by Lagrange mean value theorem? So Lagrange mean value theorem, okay. Fx is a real valued function. Fx is real valued function in closed interval AB, right. In that case it is differentiable between AB. F dash C is equal to C belong to AB, open interval, and F dash C is equal to FB minus FA upon B minus E, right. It is illustrated. So C belong to between A and B. F dash C is equal to FB minus FA upon B minus E. Now in the case of, there is a value, this is a curve, it is A and it is B, here C lies between this one open interval, here FA, and this is a FB. There are 2 points between AB. It is A and it is B. Okay. Tangent is here. F dash at this point. F dash C is equal to FB minus FA upon B minus A. Slope of tangent at C. Slope of AB. AB, slope of AB. Slope of AB is equal to slope of chord AB. Slope of tangent. Slope of tangent. Tangent. Right? So F dash C. F dash C is equal to FB minus FA upon B minus A. Okay, this is M. Now these are the very important formula for the differentiation, right? These formulas are essential to solve the differential questions. Okay. Now find there is a question, find the derivative of find the derivative of e power x upon sin x. So now let y is equal to e power x upon sin x. Okay, dy by dx, this is equal to, using quotient rule, so that will be sin x into d dx of e power x, so e power x minus e power x into d dx of sin x cos x whole upon sin x whole square, sin square x. Now this is equal to e power x common sin x minus cos x upon sin square x. Okay, this is the result. Clear? Any doubt here? Now question is that find dy by dx at x is equal to pi by 2, y is equal to, where y is equal to e power sin x. First of all, dy by dx, therefore dy by dx, this is equal to e power sin x, okay, into cos x, e power sin x into cos x. Now therefore dy by dx at x is equal to pi by 2, we get e power sin pi by 2 1 into cos pi by 2 0, into 0, this is equal to 0. Clear? Therefore we get the value is equal to 0. This is the dear student, today I over the class, and next class tomorrow I will see the class. Okay, thanks for watching video, and like and subscribe so much. I heartily wish to your best.